Rice University's Fundamentals of Computer Engineering, ELEC 220, is required of all students who expect to major in computer science or electrical engineering. This past semester, the enrollment was approximately 170, consisting predominantly of first-year students. The students begin this class with remarkably diverse backgrounds, from students who have never written any code to students who had participated in hackathons with Arduinos. I am Ray Seymour, a professor in the practice at Rice University. I teach ELEC 220. This past semester was one of transition for the course. Previously, labs were done in a small room with a capacity of about 24 students with fixed, dedicated desktop computers. This past semester, the lab was moved into a newly constructed space at Rice University. Dubbed the Classroom of the Future, this space is flat and open with windows on three sides bringing in natural light. Tables, chairs, and whiteboards are on wheels. We use this to create pods from 2 large tables with 4 students per pod. The room can easily support 24 to 32 students. Rather than using fixed, dedicated desktop computers, as was done in the past, each student used their own laptop in lab. Additionally, each student purchased their own mobile hands-on platform consisting of 3 parts. First, a TM4C123G Launchpad, which is ARM M4F based. Second, the Sidekick basic kit for the TILaunchpad that includes a breadboard, jumper wires, and other components. And finally, an installation of Code Composer Studio development environment on their laptop. This move to a student-owned mobile hands-on platform had several benefits, including students did tinkering outside of the classroom and lab settings. Theory was demonstrated in the lecture hall using the same mobile hands-on platform they used in the lab. This avoided a centralized lab and its limited access to the fixed, dedicated desktop computers. The open lab space was laid out to give the labbies plenty of room to move between the pods of students, making it easy to quickly get to those students who had questions. Attentive labbies identified those students who needed additional help. Students who were quicker to get their lab working often found themselves switching from individual work to helping out your neighbor mode. With the visibility that CCS gives us into the M4F on the Launchpad and the use of the Sidekick, we could introduce our students to key fundamental concepts in computer engineering. Some of the topics included how data types are represented in data and program memory, an introduction to CPU architecture and sequential processing, memory hierarchy and memory-mapped peripherals, basic input and output, and synchronization of the CPU with complex peripherals. By gaining this exposure, the students are able to decide on their future path at Rice, whether it be compilers, computer architecture, embedded systems design, operating systems, logic design, or any of the other many specializations that are available at the undergraduate level. Tentatively, early one-on-one student feedback has been positive. The students in ELEC 220 will be doing a course evaluation, and we hope to learn more about the strengths and weaknesses of this approach from their perspective. Thanks for your time today.